Okay, so here we shall give the definition of increasing and decreasing functions and related theorems with an example. So the definition of increasing and decreasing function, the definition of increasing and decreasing function is that let I be an interval contained in the domain of a real valued function f. Let I be an interval Let I be an interval contained in the domain of a real valued function, contained in the domain of a real valued function f. Okay. Uh, I be an interval contained in the domain of a real valued function f. Then f is said to be increasing function. F is said to be an increasing function on the interval I if x1 is less than x2 in the interval I, also implies that f of x1 is less than or equal to f of x2 for all x1 comma x2 belongs to that closed interval I. Second is that it is called as a strictly increasing function. It is called, then f is said to be strictly increasing function on the interval I if x1 is less than x2 in the interval I. It also implies that f of x1 is less than f of x2 for all x1 comma x2 belongs to I. And then the third case is f is said to be a constant function on the interval I if the function f of x that is always equal to some constant c for all x belongs to the interval I where c is a constant, where c is a real constant. And the fourth case is f is called f is said to be a f is said to be a decreasing function, said to be decreasing on the interval I if x1 less than x2 in the interval I also implies that f of x1 is greater than or equal to f of x2 for all x1 comma x2 belongs to that interval I. Then the fifth case is f is said to be a strictly decreasing function, is said to be strictly decreasing function on the interval I if x1 is less than x2 in the interval I also implies that f of x1 is greater than f of x2 for all x1 comma x2 belongs to that interval I. So the graphical representation is that suppose this is x-axis, this is the y-axis, and if we have a function suppose like this, so this is y equal to f of x. So this function we can see as we increase the value of x, x1 and x2, then the function value also will increase. It means f of x2 will be obviously greater than f of x1. And so this is an example of strictly increasing function, strictly increasing. And suppose if we have a function like this is x-axis, this is y-axis. And so the function is suppose like this. Then here we can see that as we increase the value of x, x1, x2 is greater than x1, then the function's value is decreasing actually. Means f of x2 is obviously less than f of x1. So this is an example of strictly decreasing function. Strictly decreasing function. And suppose if a function is a constant function, means it is like this. This is y equal to some constant k, suppose. So then here we can see that x1 and x2, if x2 is not equal to x1, then also the value of the function is constant k. Means f of x1 that is equal to f of x2, that is equal to that constant k. But here x1 is not equal to x2. So it is called as a constant function. So this is an example of constant function. So constant function, it means that which is neither increasing nor decreasing. Constant means it is neither increasing nor decreasing. So hope you have understood. Then so we can understand this by one example. That is, suppose it is asked to show that the function given by the function given by f of x that is equal to 7x minus 3 is an increasing function on the set of real numbers R. Is increasing on R. R means the set of all real numbers. So here, so let x1 is less than x2, where both x1 and x2 are two real numbers. x1 comma x2 belongs to R. So then it means that 7x1 is obviously less than 7x2. And it also means 7x1 minus 3 is also less than 7x2 minus 3. So this means that f of x1 that is less than f of x2. So it means that x1 is less than x2. It means that f of x1 is less than f of x2. Therefore, we can say by the definition of decreasing and increasing functions, by the definition, so by the definition on increasing and decreasing functions, increasing and decreasing functions, we can say that this function f of x is increasing on R. We can say that the function f of x is strictly increasing on R. Strictly increasing on the set of real numbers R. So now on these increasing and decreasing functions, we have one theorem. So let's state that theorem. The theorem is that let f be a continuous function. Let f be a continuous function. Let f be a continuous function on the closed interval a to b, and let f be also differentiable. Let f be also differentiable in the open interval a to b. Then the first rule is that the function f is increasing. The f is increasing in the closed interval a to b if the derivative of x, if the f dash x that is greater than 0 for each value of x belongs to the open interval a to b. And the next is f is strictly decreasing in the closed interval a to b if the derivative of f of x, if f dash x is less than 0 for each value of x which belongs to the open interval a to b. And the third case is the function f is called a constant function. F is a constant function. F is a constant function in the closed interval a to b if the derivative of f, if f dash x that is equal to 0 for each value of x belongs to the open interval a to b. So hope that you have understood the. So this theorem can be proved by using the mean value theorem. So hope you have understood the concept. Thank you.